What's going on, guys? Assalamu alaikum. Welcome to Ms.My Code. In this video, I want to go over with you how you're going to master Java. This video was requested by a lot of you guys, so I decided just to basically just bring it all and have like a roadmap for you so that you know exactly what to focus when learning Java. So if you're new to my channel, go ahead and subscribe, give me a thumbs up so I can keep on recording these videos. And if you're not part of the Ms.My Code community, go ahead and join. The community has over 30,000 people combined, and I hope to see you there. So this is for someone that wants to master Java, and maybe you're just starting out your career and you want to basically have like a breakdown of some of the things that you should be focusing on. Then this video is for you. So I'm not going to waste too much time in detail because this could be in hours and hours of content, but at glance in here, so let's just start with this purple line here. So I felt like it was really necessary for me to include Git because Git is essential for any programming language, right? So whether you want to learn how to work within a team or collaborate with others, then Git is a must for every single engineer depending on the language. So I have a course on Git and GitHub Essentials, and if you've missed that course, go ahead and enroll absolutely for free. So then moving on to core. So core, this is where I've mentioned like interfaces, OOP, variables, classes, loops, inheritance, and other things, right? But this is the core of Java. Now, if you're not confident on how to work with interfaces, classes, and all these things, then I definitely recommend you to check my course on Java where I teach all of the basics. But for example, you should be able to understand, for example, what is the final keyword, how to put all of these classes together, packages, for example, what are they used for? So before you move on, you need to understand exactly how all of this works. Then for the advanced section in here, so this is stuff like dependency injection, how the garbage collection works, design patterns, how the JVM works, best practices, and basic of threads. So in here, I feel like you probably don't have to master everything because the goal here is for you to understand like how the language works. Because once you know how the language works internally, then when writing code, you will take all of these things into consideration. So also here you see that I said basics of threads. So these days, resources is not a limitation as before where we had like limited resources. And yeah, so today we run most of our software in the cloud using Kubernetes. So, just know exactly, for example, the basics. And, writing multi-threaded applications, it's very hard. And usually people get it wrong. So you're not going to be writing lots of multi-threaded applications these days because of the cloud. You can scale if your application has a lot more traffic. And basically, if you need more resources, Kubernetes, for example, can auto scale for you, right? Or whatever cloud technology that you are using, that should be taken care by the cloud itself, right? And not you having to, have, for example, one map and then make sure that it's concurrent, on and so forth. So don't do that. Also for design patterns, I would say like don't learn every single design pattern because, so again here, you're not going to use everything. So my recommendation is learn what you need, right? And learn, for example, the most used ones, for example, singleton, for example, right? Then dependency injection, it's very important I understand why we have dependency injection, the benefits. So I've got a course on that as well. Then moving on to build tools. So here I would say Maven or Gradle. So Maven basically it allows you to manage your dependencies, and also you can package up your application, you can run tests and a bunch of things. So Maven has phases, and this is a separate topic. And if you want to learn more about Maven, I'm actually planning a course on Maven. So please let me know whether you want to see it or not, and I can make it happen as soon as possible. But I would say like pick Maven instead of Gradle, because Gradle, the learning curve is much higher for Gradle, and you'll find more examples out there with Maven. Then moving on to databases. So the way you're going to master Java is for the backend side of things. If you don't know how to work with databases, then it's going to be really difficult for you. So what I would say is, so here you need to learn JDBC. So this is raw, JDBC. So how to connect to a database, how to execute queries using pure Java. Then obviously, like once you know like the basics, then you should adapt to a framework. So for example, JDBI or JDBC template for Spring and others. But if you know, for example, how it works behind the scenes, then moving to a framework shouldn't be that difficult. Then SQL, so you need to know SQL, so relational databases, database constraints, transactions, indexes, joins, queries, database administration. So you need to know, or you need to be aware of everything. And I would say like you need to kind of have a good understanding about everything apart from database administration, right? So for example, if you have an application and the main screen, for example, takes a while to load, maybe you are missing an index, right? So if you had an index, then the query becomes faster, and then you have happy users. So also like joins, how to join one or more or two or more tables together, queries, so making sure that you use the right queries so that they are fast. So I've got a complete course on Postgres and SQL ready for you, absolutely for free as well. Then ORM, so object relational mapping. So this is where you have your Java classes mapping directly to your database. Now in here you see JPA, so this is the interface, so the specification, and then you have implementation such as Hibernate, which is quite popular, and Spring Data JPA in here. So these are one of the two most popular ones that you're going to be using. Then moving on to logging. So in here, so just have an understanding how logging works, and also log enough. So just imagine the scenario where you deployed an application to an environment and basically have no logs, you have no visibility of what is happening, and you have a bunch of errors, right? So if you don't have the logs, then it's very difficult for you to debug. And usually if you have logs and then along with correlation IDs, then you can trace the request that goes through your system, and it's much easier for you to debug that way. And to be honest, I've never worked in a place where there isn't logging, to be honest. So logging, it's very critical for your application as well as for the operational side of things, right? So it's really important. So here, just have the basics. So logging to standard out or file, and then appenders. The differences of logging frameworks such as SLA4j and others. Then in here, I would say like testing. So before I just move to frameworks, I'll say testing. It's very important. So never write a single line of code without testing it. Like, there are lines of codes that doesn't really make sense. For example, getters and setters, you shouldn't be testing those. But business logic, make sure to test it. Business logic, make sure to test it. So here with testing, you have unit testing. Then you need to learn about assertion libraries. So for example, assert4j, which provides you an extensive API. For example, you can say assert that an object dot and then equals to and then whatever, right? Then mocking, so understand why you need mocking. So you shouldn't really be testing two services. So you test one in isolation, and then the other one, if it has a dependency, then you actually mock it. So I also have a course on testing ready for you that covers all of this. Then you also have integration testing. So this is where the application comes up as a whole, and then you test, for example, your endpoints, right? For example, your get requests, your post requests, your delete requests, and then you see like the request, how it flows through the system. And then you have contract testing as well, which is really important. But I would say, as you start, then focus more on integration testing, unit testing, and debugging. So these are skills really important to, help you to write solid software. And basically, testing is here to help you write better software. That's really the purpose of testing. So test your code. And then finally, I would say like frameworks. So here, it's good that you learn Java without a framework, but in the long run, like, don't write everything yourself, because this is why you have frameworks, right? So the same with JavaScript. People wouldn't use jQuery. They would mainly use like React or Vue or Angular. So these are frameworks. So the same in the Java world, you have frameworks. So here you have Spring Boot, which is one of the most popular ones, and you also have Play framework. So it's not so popular as Spring Boot. You've got Quarkus and others. And to be honest, I think this is it. So let me know what you thought about this video, whether I've missed something, or if you want to, just improve on this, just let me know. I'm going to leave a link where you can find all of this diagram and also the blog post. And if you're new to my channel, go ahead and subscribe. Give me a thumbs up so I can keep on recording these videos. If you're not part of the Amigos Code community, join. Over 30,000 people combined, and I would love to see you there. This is all for now. I'll catch you on the next one. Assalamu alaikum.